Okay, next we'll turn to Module 3 in Chapter 10, where we'll look at the construction of the binomial model. So far we've seen how we can price options if the U and the D are given, and in this section we'll look a little more closely at what are the implications of that choice. So if we're constructing a binomial tree, an important point is, what if there were no uncertainty in the price of the stock at time t plus h? The value of the stock today is st, and if there were no uncertainty in the price at time t plus h, its price would have to be the forward price. That would be enforced by arbitrage, namely that if there was, and what is the forward price? It's exactly st times e to the r minus delta h. So in the absence of risk, the price of every security in the future would have to equal its forward price, otherwise you could arbitrage it. Again, it's risk-free. If you knew that the price of the stock was going to be greater than this forward value, you would go long the stock and you would short a forward, and so forth. So now what happens if there is uncertainty? Well, it makes sense to change the forward value, which is the value without uncertainty, by a factor which is some reflection of volatility. By convention, we write this as an exponential factor. There's some mathematical reasons for doing that, but one could imagine that the risk of the price could be reflected mathematically in a variety of ways. This is a very convenient way to do it. And so sigma here reflects the annualized standard deviation of the continuously compounded return. So here sigma is the annualized standard deviation. So it's the standard deviation of returns over a year, and it's using a continuously compounded model. We'll see that model in more detail in a later module, and we'll also see in that later module that standard deviations over shorter periods than a year go with the square root of time. So if h, for example, is a month, which is 1/12 of a year, the annual standard deviation sigma would become sigma square root of a 12th. So h will be measured relative to years, and standard deviation over subperiods goes with square root of time. Again, both of these points will be studied later in more detail. So if we just rewrite this formula, we get an expression for u and d. Namely, the return u is the forward return plus a standard deviation, and the return d is the forward return minus the standard deviation. And this is sometimes referred to as a forward tree, that where we assume stock prices will have this behavior.